In this lesson, we're going to take a look at velocity time graphs, and you guys just created these in a lab. Hopefully they make sense to you. I just want to review a few things with you. First, remember that we can get velocity from a position time graph. Remember, position is distance and direction from a reference point, and motion means the position is changing. Velocity is really the rate of change of position. It tells us how fast position is changing. So we look at a position time graph and we look at the slope or the steepness of the graph to understand how fast it's going, and we look at the sign of the slope to understand how or which direction it's moving. So if I had a graph that started here and went like this, I can look at that and I can say it's got a positive slope, which means it's moving away, and it's fairly steep, which means it's moving fairly quick. I could even say it moved 5 meters in 5 seconds. It's moving at 1 meter per second. Whereas if I took and I drew this one, okay, it's still positive, but it's not as steep. It's moving a little bit slower. And I could start and I could go the other way, start at 3 meters and move my way back down towards the reference point. This is a negative slope. It's moving towards the reference point. It's fairly slow. It's not very steep, as opposed to this graph, which is pretty steep. It's negative, so it's moving fast towards the reference point. Okay, so velocity, speed with direction, and the slope of the position time graph tells me that. The direction of the slope tells me the direction of the motion. The steepness of the slope tells me speed. Now, let's take a look at velocity time graphs. These are new. These are what you were just investigating in lab, and they don't show what a position time graph shows. Position tells me where something is at every point in time. Velocity tells me the speed and direction at every point in time. Okay? They show speed and direction. They do not show position. Okay? Now, the speed is the numerical value, so it could be -2 or +2 for velocity, but there's no such thing as negative speed. That indicates a direction. So the direction is given by the positive up here. So it sometimes helps to remember that anything above the line on a velocity time graph is positive. That's away. Anything below the line on the velocity time graph is negative, and that means towards. So it's this dividing line that separates the motion. Okay, it's not the direction of which the velocity graph is sloped. It's actually if the line is positive or negative. Remember, positive velocity means away, negative velocity means towards. So sometimes it's just handy to label your graph like that so you know, you remember what's going on. Okay, away positive, towards negative. And because it only shows speed and direction, you cannot find where it's at. You can tell me how fast it's moving, you can tell me which direction it's moving, but you don't know where it is based on just the velocity time graph. Now, let's take a look at comparing these two graphs. Position time graphs, if I'm going to move fast on a position time graph, I need it to be a fairly steep slope. Okay, so I'm going to go from the reference point, and I'm going to go up 2 meters every second. 2 meters in 1 second, 2 meters in 1 second, 2 meters in 1 second. That's fairly quick. On my velocity time graph, that looks like this, 2 meters in 1 second. You'll notice it's positive velocity because I have a positive slope, and the slope over here is 2, so my velocity over here is 2. It's a constant speed of 2 meters per second away. Now, if I was going to go slower, let me do this one in a different color. Let's go with blue. Okay? At a slow constant speed, let's say half a meter per second. So in 2 seconds I go 1 meter. In 2 seconds I go 1 meter. In 2 seconds I go 1 meter. If I have this speed, it's still a positive velocity. It's still moving away from the origin, but it's very, very slow. So instead of up at 2 meters per second, I'm down here at half a meter per second. It is still constant, it's still horizontal line, and it's still positive because I'm moving away, but it is closer to 0, right? The slowest we can possibly go is rest, and at rest looks like this, looks like a horizontal line. There is no velocity here, and that would be on the axis there. Now, let's go the other direction. If I'm moving towards the reference point, that means I have to start far from it and get closer. And if I do this slowly, say like 1 meter per second, then my position changes 1 meter every second, and I end up moving towards the reference point. Now, on my velocity time graph, that's going to look like this. I'm moving at 1 meter per second in a negative direction, or towards the reference point. And I continue moving at that 1 meter per second for the entire duration. So this is a horizontal line below the axis. And it's fairly close to zero because it's fairly slow. Whereas if I was to move faster, and towards the reference point, say 2 meters or even 3 meters per second. Like if I was going 3 meters in 1 second, 3 meters in 1 second, but it's negative slope, it's towards the reference point, that's this graph. It's down here because I'm moving at a constant speed of negative or of 3 meters per second in a negative direction. Okay? So negative velocity is towards, positive velocity is away. Now, one more case to look at is when we change direction and still. Remember, I showed you this position time graph. Still means the position doesn't change. It was at 3 meters, it remains at 3 meters. That means my velocity is 0. We're not moving. We have no speed. Now, if we change direction on a position time graph, that means the slope has to change from a positive slope to a negative slope. Okay? That's not a big deal. We're moving away and then moving towards. That means my velocity has to change from positive for the first 3 seconds, how I drew it, to negative, which means it's going to jump down to this -1. Now, in real life, we can't instantly change direction, but we can draw it. So we're going to draw it. And then this hung out down here at -1 meters per second for a little bit. Okay, so this is a direction change. It crosses the axis, that changes direction. It's on the axis, that means it is not moving. So still, velocity equals 0. Changing direction, velocity crosses 0. And if you think about that, you have to stop before you can switch direction. So velocity crosses 0 means we change direction. Velocity is 0 means the object is at rest.